In this next section, we're looking at some more trig identities. Going back to last chapter, is this the graph of a sine or a cosine function? So we might be inclined to say sine because it starts on the midline at the origin and goes up. But remember, we wrote all of those sinusoidal equations saying, well, this could be a sine function if I start here, or I could look at it as a cosine function that's been shifted to the right or shifted to the left and reflected. So the answer is that it's both. If we were to shift this over to the right, assuming this is a period of 2 pi, then the cosine graph, it could be a y equals sine x graph, or it could be a y equals cosine of, shift this to the right, like x plus pi over 2. Oh, sorry, not plus, x minus pi over 2. It could be negative cosine x plus pi over 2. There's all kinds of combinations here. So you could have either a sine or a cosine function depending on how you shift it. The same is true if we were to look at tangent x versus cotangent x. They are just horizontal shifts of each other. Now, when I wrote my cosine shift, I said x minus pi over 2. What we're going to learn are these cofunction identities. And so sine and cosine are horizontal shifts by pi over 2 of one another. They actually switch, for these identities, we usually switch the order of subtraction here, and I can explain that using triangles in a minute, but here's our first cofunction identity. If we see an expression that says the sine of pi over 2 minus x, that's equal to cosine of x. Now we could go around this and say, all right, this is factor out a negative x minus pi over 2. If we were to reflect the sine graph around the y-axis and then shift it pi over 2 units left or right, we would land on a cosine graph. So that's part of the reason here. We can look at this with triangles as well, but just to get the rest of our identities down. If this is true for sine, then this is also true for cosecant. So the cosecant of pi over 2 minus x should then equal the secant of x. That's because we can just say 1 over sine equals 1 over cosine, so same idea there. We can also switch the order of this, so the cosine of pi over 2 minus x should then equal the sine of x. Basically, when we're using these identities, we just always want to get rid of the pi over 2 minus x side and simplify it. So the reciprocals are true. The secant of pi over 2 minus x is equal to the cosecant of x. And finally, we didn't look at graphs, but it's also true that the tangent of pi over 2 minus x is equal to the cotangent of x. I could be using theta here, by the way. It doesn't matter. And cotangent of pi over 2 minus x is equal to tangent of x. Okay, next set of identities I want to look at are the even and odd identities. So here's a portion of the sine graph. Is the sine function even or odd? Okay, so remember, odd is origin symmetry. So this is the sine graph. It's odd, which again means origin symmetry. And function notation wise, because we see this on our AP test, what this means is f of negative x is equal to the opposite of f of x. That negative sign, just read it as opposite. So that just means that, yeah, when I plug in a negative angle on the sine curve, I get this negative value. When I plug in a positive angle, I get this positive value. So in this case, that means that the sine of negative x is equal to the negative sine of x. That's our first even and odd identity. If we see the sine of negative x, if we see a negative in an angle, we're going to simplify it to the negative sine of x. And if that's true for sine, then it's also true for cosecant. Cosecant of negative x is equal to negative cosecant x. Take a look at the cosine graph. Is the cosine graph even or odd? So even, because you have y-axis symmetry. And that means that Whether I have negative x or x, I get the same value. So f of negative x is equal to f of x, same height there. And so that means that cosine of negative x is equal to positive cosine of x. So if we see cosine of negative x using our even and odd identities, we're going to simplify that and say cosine of negative x, we're just going to rewrite that as cosine of x because they're equivalent. If I said find the cosine of pi over 6 and find the cosine of negative pi over 6, both of those answers are radical 3 over 2. If that's true for cosine, it's true for secants as well, so fill in your secant identity. And finally, tangent. Tangent is odd. It's got that origin symmetry, which means that f of negative x is equal to negative f of x. And that means that anytime we see tangent of negative x, that equals negative tangent x. So there's our third set of identities. Tangent of negative x equals equals negative tangent of x. And cotangent of negative x equals negative cotangent of x. So that's our two new sets of identities that we're learning, the cofunction identities and the even and odd identities. All right, so let's use them in some proofs. Like I said, anytime you see a strange expression in the angle, like pi over 2 minus x or negative x, we're going to rewrite that. All right, so verify each identity. We're going to start on the more complicated side. Cotangent of pi over 2 minus x, if you check your chart on the previous page, that's equal to tangent of x times cosine x. We're trying to get this equal to sine x. Anytime I see a tangent and a sine or a cosine, I rewrite tangent using quotient identities, sine over cosine. Those cosines are going to cancel, and I'm left with sine x. Right, on this one, I want to start here before I expand anything out. I'm going to change this so that it's sine x, and remember the cosine of negative x is equal to cosine x, so this is just plus cosine x squared. We should square this out, so squaring a binomial, you get sine squared x plus 2 sine x cosine x plus cosine squared x. And we know that sine squared plus cosine squared is the Pythagorean identity. It's equal to 1. And this is what we were supposed to show. All right, now sometimes you see the pi over 2 minus x inside of a squared function. So remember, this means cosine of pi over 2 minus x squared. So first simplify this. Cosine of pi over 2 minus x is sine, and then it's sine squared. So you are allowed to apply the cofunction identity, even if this means squared. It's just that you get sine squared over cosine x. These identities hopefully feel pretty basic compared to what we just did over the last couple of days. So sine squared is like sine over cosine times another sine. We're supposed to show sine times tangent, so I'm going to put sine x first, and sine over cosine is tangent. Okay. What about cosine of 5 pi over 2? That's not our identity, so we need to make sure, we need to double check that, like, does this land in the same spot? Is this coterminal? Is this coterminal to pi over 2? All right, so pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Yeah, it is coterminal. So cotangent of, or cosine of 5 pi over 2 is the same as cosine of pi over 2. Those values will be the same. So I can rewrite this to say, well, this is really just the cosine of pi over 2 minus x. And down here, the order is backwards. So let's rewrite the sine function too. The order of subtraction does matter. Oops, pi over 2 minus x. Okay, so sorry, I'm trying to get my pen here. There we go. Okay, so we've rewritten the top, so that's clearly sine. sine x on top. And then what about the bottom? So we have this cofunction identity, but we can't use the cofunction identity until this negative is out of here. So remember, the sine of a negative angle, let's use theta instead of x, is equal to negative sine of theta. And theta equals this expression in this case. So we should take this negative sign and pull it out front. Negative sine of pi over 2 minus x. And now that's negative cosine. So sine x over negative cosine x. And we're trying to show that we get negative tangent x. So just one final step to show that that's negative tangent x. Okay, so just to summarize some more guidelines for verifying identities. If you see cofunction identities and negative angles, that should be your first thing to take care of. Even if you see obvious next steps in the proof, get rid of negative angles, get rid of cofunction identities. And then we still work on the more complicated side, and we're still running through the same list that we've been running through for the last few days. Can we factor a side? Can we distribute on one side? Are there common denominators to set up? If I rewrite in terms of sine and cosine, will I get some things to cancel? So all of the same rules apply after you fix your negative angles and cofunction identities. All right, that's it for today's notes.